I saw here Ariel is connecting to audio. Can you hear me, Ariel? Or you are still connecting to the... Can you hear me? If you can hear me, you let me know in the chat. Not responding. Maybe cannot hear. Is it? Yeah. Okay, we'll just continue. Don't waste any more time. Okay, now let's say I have an object here. 5n forces acting upward and another 5n forces acting to the right. What is the resultant force? Now, whenever you do this type of question, first you treat the object as a point, 把它当作一个点, right? So this one, I just write a point, and then I sketch the forces diagram. Okay, so you have two forces here, 5n and 5n here. So both acting at different direction. Now we use one method called the head to nose to tail method, meaning that I take one forces, it can be any forces. Let's take the vertical one first, the one pointing upward. Okay, so we start at this point, draw it up, label it 5n, okay, vertical, and then I take the other forces. So you will join the tail of the other forces to this tip right here, like this, 5n. So this is we call vector summation. Okay, it's a vector summation, sum of vector. So this one 5n. Now bear in mind that if you have 5n and 5n 一样大是一样的 magnitude 一样是意思说你的这个 arrow the length should be 一样。Okay, the length should be the same. And also you have to know that here is 90 degree. Why? Because here is perpendicular, right? This force is perpendicular this force. Okay, unless it's stated otherwise. Okay, so 5n. So here, now you join the starting point straight to the ending point right here. So this is the resultant. Okay, this is Fr. Now, if I want you to calculate the resultant force, what is the magnitude? So this one, you use the Pythagoras theorem you learn in mathematics, right? So Fr, 记得那个 a square equals to b square plus c square. Yeah, 讲啊。现在我 pen lag 一下。Okay. So a square equals to b square plus c square. So Fr equals to square root of 5 square plus 5 square. So this one, if you do the math, you will get 7.07 Newton. Okay. So this one Fr is 7.07 Newton. Now the direction, so you always want to find the direction. Okay, so this one 90 degree here, meaning that here must be 45, here must be 45. Okay, so your final answer is you draw a Cartesian plane. Here you have your y-axis, you have your x-axis, and then you label the resultant force. This is the single point origin. This is your resultant force Fr, and it's 7.07 Newton, and the angle here, I do it over here, is 45 degree. Okay, this is how you properly find the resultant force. Okay, now next, another question. Let's try another one. So this one is about finding resultant force, okay, given many individual forces. Okay, now next one, let's do this one, like object. We have force acting downward, 12N, 4N here, and then okay, now find the resultant force of this system. Okay, so first step you want to do is you find the Fx and Fy, meaning that the vertical component and the horizontal component of forces. Okay, so let's do the horizontal component. Horizontal component, meaning that you sum them up. You sum all the horizontal forces up. Okay, so the summation, so F, I write Fx horizontal equals to 10 is positive 10N minus 4N. Okay, so equals to 6N, and is acting to the right. So vertical component. Now for vertical component, you write Fy equals to, okay, the top acting upward, you have two forces, so 5N plus 3N, and then you have other direction, which is minus 12N. 8减12减4, so negative 4N. So this is acting down, and this is acting to the right. Now, after you find the horizontal and vertical component of forces, then you draw it out clearer, you can see. So this one, it becomes like this. I have here acting to the right, and I have Fx equals to liu n, and then I have Fy downwards equals to, again, don't write negative, just 4N. Okay, so you already sum them up into vertical component, then you find the resultant. So use the coordinate system, this one. So write your forces. First, you have, starting from here, your point. Okay, so to the right, 6N, and down 4N. Okay, so you join the line from starting to ending, put double arrow. This is your resultant force. Yeah, so how do you calculate this resultant force? Again, this is the right angle triangle. So you can use this one, Fr 等于 6 square 加6 square 等于 this is 7.211 Newton. Okay, so this one is direction, this one is magnitude. Now you find your direction. Direction is the degree angle here. Okay, this one over here, the one I labeled pink color. Okay, so you have to find this. So how to find this one? You use the what? Sine, cos, tangent. Tangent, theta, equals to tangent is opposite and adjacent, right? So the opposite of the angle theta would be 4 divided by the adjacent would be 6. So theta equals to tangent minus 1, 4 divided by 6 equals to 33.69 degree. Okay, these are just mathematics. Okay, now, so after you find the magnitude and the direction, then you draw the final diagram, the final force diagram, your resultant force. So here is your Cartesian, resultant force acting like here, label Fr equals to 7.211 Newton, and then label the angle here. This is 33.69. This is the vector representation of your resultant force. Okay. Now, any question before I move on? No question. Okay. Now, just now we have talked about two forces can be combined to get a resultant force. Let's say Fy and Fx combine to get this one over here, F resultant. Okay, so I draw the dotted line, this one. Now, same, this process, we can reverse this process, meaning that we start with resultant force. We start with any force, not only resultant. We start with any force that is not that is diagonal. Any force that is diagonal, we can resolve that into vertical and horizontal component. Okay, so this one is just the opposite of the first process. Okay, so F, I can also resolve it back to Fy and Fx. Okay, so given any force, I can break down it and resolve it into the vertical and horizontal component. And this process is the reverse of the first process. Okay, so this process, we said the resolution of forces. Okay, resolution of forces. Okay, like so every time you see I mention resolving the forces, meaning that you break down, make it vertical and horizontal component. Any diagonal forces can be resolved into vertical and horizontal component. Okay, now remember this one, very important. Okay, now again I repeat, horizontal vertical component can be combined to get resultant force, and this is diagonal. So conversely, I can also reverse the process by taking a force, diagonal force, and resolve it into vertical and horizontal forces. Okay, now how do we do that? Let's take a look at an example. Okay, now let's say I give you an example here. Okay, you have an object acting by a force, and this is diagonal force, F equals to 10N, and it is 30 degrees from the horizontal line. Okay, so question 1, find the horizontal component of force. Find the horizontal component of the force. So first step you do is, again, Cartesian plane. If you put this one in the Cartesian plane, this one is the F10N. Okay, so here you actually can put the dotted line here, and this one is actually a right angle triangle. Okay, you can treat it as a right angle triangle where this is 90 degree and here is 30 degree. Okay, and the slanted line is 10 Newton. So find the horizontal component of force, meaning that you want to find this one here, the red arrow, okay, on the x-axis. Now, how do you find that? Using the mathematics sine cos tangent, like this, 30 degree here. So this is 10n. You want to find at the bottom this one, fx. I write fx, okay, horizontal component. And this one is actually fy, vertical component. Okay, now to find fx, what do you use? You use cos. Cos 如果我 cos 30就是所掐多掐就是 c ah 嘛，是不是？ So ah meaning that it is what? Adjacent divided by 10. Adjacent divided by 10. So you can move this over there. So fx equals to 10 cos 30 degree. Okay, so the horizontal component is 10 cos 30 degree. So if you calculate it, then you will get a 8.66 n Newton. Okay, 8.66 n Newton. Now, this is for question 1. So if question 2 I ask you to find vertical component. Now again, we use the same diagram. Okay, so this time vertical component is fy. I want to find fy. So what do we use? We use sine 30 degree. Okay, look at the diagram over here, down at the bottom left. Sine, then which one I take? Sine is OH. So, okay, so focus on the angle 30 degree over here. So the opposite would be opposite to the angle. The side opposite to the angle, which is Fy, divided by hypotenuse is always the slanted one, always the inclined one. So 10 Newton. Okay, so we use sine, and then this one, we move it over there. So Fy equals to 10n. Okay, I'll just write 10. 10 sine 30, which is equals to 5. So here you have your vertical and horizontal component. Okay, so again, if you want to, so every time you don't have to repeat this process. Okay, you don't have to do from the first show exact solution like this. You can actually take a shortcut like this. You look at it like this. For example, if you have a resultant force here, Fr, okay, and given the angle over here, let's say 40 lah. Okay, to find the horizontal component, you just, if you take Fr cos 40, then you are finding the horizontal one. Okay, 把它想成这样子，如果你拿 Fr cos 这一个 angle 呢，就是很像等于你把这个线拉下来这样子，把它拉下来，然后等于平衡 horizontal. So this one is the horizontal component of forces. So whenever you want to find horizontal component, just take the Fr cos the angle, right? So if you take Fr sine the same angle, meaning that imagine this one, 把它想成这个给推上去 ，OK， 那个线给推上去，becomes a vertical line. Okay, so Fr sine 40 is the vertical component. Okay, FR sine 40 is the vertical component. So I write Fx equals to 这一个 cos 这个，然后 Fy equals to these two. Alright? Later I'll give you another example, just not to confuse, just to give you more clearer picture. Okay, so yeah, back to this question. So this question, you got the Fx and Fy, so you can label on the diagram here. So I just label for you so that you can see it. Okay, so this one you can write. So the horizontal here, see the diagram above. This one pink color one is my Fy 等于5n， 然后我的 Fx 等于8.66n。 Okay, so these two, you will get these two. Also, if you combine these two, of course, you will get back your resultant force, which is the 10n. So this is how we resolve forces back into vertical and horizontal component. Okay, now let's do another this one. Just now I mentioned the cos and sine one. Okay, 如果你有 let's say you have like this, and then your line is over here, and here is 60. Now this is F equals to 10. Now find the horizontal component of this force. So this force, if you take force 10n, if you cos the angle, meaning that you pull down, okay, 把它拉，就是很像这个把它拉去那边，靠近那个 angle， 给那个 angle 拉下去，这样子，你这样子 imagine 比较容易了。给那个 angle 拉下去 ，if you cos it, okay, so this one 拉下去 becomes straight, right? So this is the horizontal Fx. So Fx is 10 cos 60. Alright? So you don't have to imagine again. 你不用再画那个三角形，然后这个 cos 这个 sin 那个。Okay, you just straight away take cos the angle. Okay, so if you take 10n sine the same angle, meaning that 你给那个 angle 推上去。Okay, 推上去 away from the angle, so becomes vertical, right? Vertical downwards, pointing down. So vertical pointing down, that is your vertical component, which is Fy. 我的笔又缩了一下。Yeah, right, I use my mouse. So this is Fy. Okay, I'm just showing you a simple and very quick way to solve it, to find the vertical and horizontal. All right? Okay, now let's move on to the next one. Okay, what time is it? 39. Okay, oh yeah, it's over. Okay, let me finish this up. Okay, at most until 6. Okay, now next one I want to talk about is, okay, let me show you 2 examples before we move on. I actually prepared 2 examples here.